One of the distinguishing characteristics that separates the men from the animals is the use of tools. You'll find several new tools useful in a new procedure for axle bearing adjustment called the lead ball method. Some of these special tools can be constructed in your own shop. The axle housing support tool is made of angle iron. Used with a Fender U-clamp, it secures the final drive housing, making it easy to work on. This tool is not required if the wheel is to remain on the axle. In situations where the wheel is not removed, the axle housing must be rotated instead of the axle. A metal strap with ends bent at 90-degree angles is used for this. A planetary installation hook is made from a half-inch rod. When used with a hoist, it simplifies the removal and installation of the planetary assembly. Even though the hook angles slightly upward, it's not impossible for the assembly to slip off, so use caution during this part of the procedure. The jacking tool is made of square tubing. Essentially, this tool will provide the support for a jack used to press out the axle shaft. Instructions for making these tools can be found in the Service Bulletin R78-50-5. Right now, we suggest that you either find or make these tools before continuing this program. And make sure you also have a hydraulic jack, 2 metal bars, a braking bar torque wrench, a bending bar torque wrench, a micrometer, torque multiplier, and some lead balls, 3/10 to 4/10 inches, or 8 to 10 millimeters in diameter. Buckshot can also be used. Sizes 1 through 000 are correct. For now, we suggest you assemble your tools, then meet us back here and push the start button. See you soon. Excuse me, do you mind if we borrow part of your lunch? It'll just take a minute. You see this cookie? If for some reason you wanted to know exactly how far apart the 2 chocolate wafers were, you could measure the gap. Or you could take the wafers apart and measure the thickness of the creamy filling inside. But let's say now that this cookie was an axle bearing you wanted to adjust. You have to know exactly the size of the clearance between the end of the axle shaft and the carrier retainer. That dimension would tell you precisely how thick your shim pack should be. Of course, in an axle bearing, there's no way to take an accurate, direct measurement of this clearance, so you have to use a filling. In this case, 2 lead balls. You see, if they're placed inside the clearance, and if the planetary assembly is torqued into place, then the lead balls will be squeezed to the exact size of the space, and they can be easily measured. This technique is the easiest, fastest, most accurate procedure we know for axle bearing adjustment. As you know, if you install a shim pack that's even a little too thick, a gap is created between the inner bearing cone and the rim of the planetary assembly. When the axle is in use, the inner bearing will move inward until it contacts the planetary assembly. This leads to premature bearing failure. It's important that the required shim thickness be measured accurately. By using the lead balls as instructed, your measurements will accomplish our main purpose, to get 0 clearance. Now we're ready to begin the actual steps of adjusting axle bearings. Your axle should be secured with the axle housing support tool if the wheel has been removed. If you'll be installing new bearings, do not remove the oil film. This film should be left on. And please keep in mind that the outer bearing should be greased only after the axle has been adjusted. Step 1 is to achieve what we'll call bearing end play. If you're beginning with a disassembled axle, do not drive the inner bearing cone all the way in. If you do, you will not achieve end play. If you're beginning with an assembled axle, check the rolling torque. This will be explained later. Then check for end play. The axle shaft should move in and out very slightly when you push and pull on it. If there is no end play, well, that's why we asked you to make that jacking tool. But first, remove the lock plate. Then remove the planetary assembly with the hook and hoist, and please, be careful. Next, install the jacking tool. The threaded studs fit through the cap screw holes on the axle housing, as you can see. Thread a nut securely on each stud. Now you can fit your jack between this support bar and the end of the axle. The rest is simply a matter of operating the jack. Press the axle out only enough so that you have noticeable axle end play. You'll notice that if wheel equipment has been left on, the jacking action will pull the housing from the axle rather than press the axle out. Either way, the jacking procedure does work. There is another method for achieving end play: hammering out the axle. If you do it this way, we ask that you replace the cap screw with an old one. Screw it in until it is bottomed out, or else you may strip the threads. And please, don't forget to put the original cap screw back in when you're finished. Now it's time to try step 1. When you've accomplished it, press the start button and we'll continue. Now that you have end play, we'll continue. Put the bronze thrust washer onto the axle shaft. It should fit against the bearing cone. All shims should be removed for the time being. Then put 2 globs of heavy grease opposite each other on the end of the axle shaft. The sticky grease will hold your lead balls in place. Press the balls into the grease, one into each glob, and make sure they're not about to fall off. The lead balls are the cream filling that we're going to measure after they're squeezed. Now put the planetary assembly back into place, but don't use any shims. The lead balls are in there, remember? Only the bronze washer should have been installed. Next, torque the cap screw to 200 foot-pounds or 271 Newton meters. This will be easier if you insert a metal bar between a planetary gear and the ring gear to prevent movement while torquing. You'll have to remove the bar for the next step. This is very important now. Revolve the planetary assembly, or the housing if the wheel is on the axle, 5 times in both directions. 5 times clockwise and 5 times counterclockwise. This allows the bearing rollers to seat themselves. Retorque to 200 foot-pounds. Remove the planetary assembly as before and pluck off the 2 lead balls. I'll go through it once more. Put the brass washer on the axle shaft. No shims. Then stick 2 lead balls to the end of the shaft directly across from each other. Install the planetary assembly and torque to 200 foot-pounds. Revolve the assembly 5 times in both directions and retorque to 200 foot-pounds. Remove the assembly and find the lead balls. Simple, really, and it's your turn to try it. We'll leave these images on for reference. Restart the projector when you've got the squashed lead balls in your hand. They look rather flat, don't they? Just like the cream filling in the cookie. The next step is easy. Measure the thickness of both balls. The average of the two is equal to the thickness of the required shim pack. Keep measuring now. Each shim needs to be measured individually. Stacked shims have a slight spring effect that your micrometer will not overcome under normal tightening. Think of the 60 thousandths washer that comes in the shim pack as just another shim, but don't assume its thickness. This one is 55 thousandths, not 60 thousandths. Shims, of course, come in different thicknesses, so you'll have to measure them and add up the right combination to equal your lead ball thickness. Right now, we'd like you to figure out the correct shim pack for your axle. Remember to average the thickness of the lead balls and to individually measure each shim and the shim pack washers. Come back when you've got it put together. Now you're ready to install the shim pack. First, you must press out the axle again to achieve end play. Otherwise, your rolling torque measurements will be false. Next, slip the cap screw through the hole in the center of the planetary assembly. Then put the shims on the cap screw, letting them hang on the threads. Install the assembly with the shim pack in position. It'll take a little fiddling around to get everything in place. Once you have it, tighten the cap screw to the final torque specified for your axle. This can be found in the technical manual. If your torque wrench is not large enough, use a torque multiplier. It has a 4-to-1 ratio, so you have to divide your required torque by 4. In other words, if you want 600 foot-pounds, you should set the torque wrench for 1/4 of 600, or 150 foot-pounds. Remember, the actual final torque for the axle you are working on can be found in the technical manual. What you use your torque wrench on, again, is the cap screw. Tighten it to its final torque. As you move the torque wrench clockwise to tighten, you'll notice the multiplier handle moves in the opposite direction. If you place a bar in the housing cap screw hole, the multiplier handle will press against it and stop revolving. After you reach final torque, turn the planetary assembly 5 revolutions in both directions as before to properly seat the bearings. You've completed this stage, but don't forget to come back. Now it's time to check the rolling torque. Place the bending bar torque wrench directly on the cap screw. Rotate the planetary assembly and read. The rolling torque should be between 10 and 23 foot-pounds. That's 10 to 23 foot-pounds, or 13 to 31 newton-meters. Of course, this procedure will not work if wheel equipment is still mounted on the axle and strapped into a stationary position. In such a case, you'll have to turn the axle housing instead of the planetary assembly. Except for that, follow the same rules. Revolve the housing 5 times in each direction, using the metal strap tool. Then take your rolling torque reading while you rotate the housing. Specifications remain the same. Rolling torque should be 10 to 23 foot-pounds. As a final procedure, install the lock plate. If the plate will not fit, turn it over and try again. If it still does not fit, continue tightening the cap screw no more than 8 degrees until the plate fits into place. Before you try this last part of the procedure, one more comment. Certain axle housings have a flat surface on one side of the casting for use in mounting. The weight of this additional casting material can affect the rolling torque if the axle is horizontal and the housing is rotated. For these housings, place this flat surface down, on the bottom. Attach your bending bar torque wrench with the handle straight up or straight down. Then rotate the housing 45 degrees in each direction and read the rolling torque. Average the results. The specification is the same as in the other procedures, 10 to 23 foot-pounds. In all procedures, if rolling torque is less than 10 or more than 23 foot-pounds, recheck your measurements. Shim thickness, lead ball thickness, repeat the adjustments. Okay? Take time now to check your parts and tools, then come back to us one last time. When your specifications prove out, we congratulate you. You've learned the quickest, simplest method for axle bearing adjustment, and the most accurate, the lead ball method. When you use it and do it well, you may have a little extra time for lunch. Just look out for the tiny hard round objects in the cookies, okay?